formula sheet and plug in the information. Now, the last problem in here did ask you to do a little bit more in terms of what we're going to be thinking about doing here. And what we want to recognize in this case, you've got multiple ways to be able to deal with this. It's a lot as to how you take a look at it. Let's get this and take a look at it. Suppose you hold a portfolio consisting of equal investments of $10,000 in 10 different companies' common stock. The portfolio's beta is 1.20. Now, suppose you decide to sell all of your holdings in one of those companies to make a $10,000 purchase. So you've got $90,000 still invested, but you've gotten rid of one stock, and that stock had a beta of 0.75. What does that tell you about the remaining portfolio? Now, there's two different ways that you could look at this. One, you could simply do it conceptually, or you could choose to do it by example. It's really up to you as to which way you go. But let's suppose we do by example. So suppose you explain by example. Now in that, what kind of portfolio do you have? Well, we know that the original beta of your portfolio equals 1.20. And we don't know anything about the items in that portfolio except for one of these, and let me call that the beta for item 10 in the portfolio. The one you're going to get rid of is 0.75. Now, this, along with the remaining items, give you an overall portfolio of 1.20. And what we know here is that the beta of a portfolio is equal to the sum of the weights times the betas of the individual items. Well, it tells us about the weights. There's $10,000 in each of 10 stocks. So the weights are all the same as 1/10. So what we know is this is 1.20, the initial portfolio beta. It's going to have a weight of 1/10 on this 0.75 that we're getting rid of, okay, in the 10th item in there. But we can make up any numbers that we want for the remainder by example to get it to balance out. Well, let's suppose that only one of them is different from 1.20. So again, let's suppose we have 8 of those items have a weight of 1/10 and a beta of 1.20. In order for this whole thing to equal 1.20, okay, that we would have, so we've got one item with a weight of 1/10 with a beta of 0.75. We've got 8 items with the weight of 1/10 with a beta of 1.20. The 10th item, okay, has a weight of 1/10, but it's got to be able to counter this one right here. So you'll notice that the 0.75 is, compared to the 1.20, it's smaller by 0.45. So suppose we put something in there that was bigger than this by 1.45, in other words, 1.65 value, then what we would see is that this one will counter this and give us our overall beta of the portfolio. Now that's kind of nice, because in this it says by example, let's suppose that we're selling off this one, then that means the portfolio that's left has these items in there. It'll have 8 items with a beta of 1.2. and 1 item with a beta of 1.65. But now, there's not 100,000 invested. We're going to spend 10,000. So we've only got 90,000 left, 10,000 each of these items. So the new portfolio would have the following beta. The beta of that portfolio, and let me see that new, it's going to be equal again to the sum of the weights times the betas, but it'll have 8 of these with a weight now of 1/9 of 1.20, and 1 of these with a weight of 1/9 of 1.65. So by example, if you solve this through, you get a value of 1.25. Okay, so that's one way to answer it. Now, a second way to have answered it is just conceptually, and to go ahead and put in and realize what goes on here, and that would be conceptually, it's true for not only this example that we gave, but it's for every example of what you could have. So the beta of the portfolio in the case of the old one equals 1.20. That's equal to the sum, and these are all 1/10 weights, of the beta I, okay, whatever they would be. In particular, it'll be equal to 1/10. We can pull that outside since it's an equal weight, times the sum of I equal 1 through 9, the first 9 of these that we don't know what they are, plus the 10th that we do know what it is. Okay, so that's true of 1.20 equals this, for whatever these 9 might be. Now the beta of the new portfolio, I'm sorry, this is the first 9 of these, and we got rid of that one. Beta of the new portfolio is going to have all of these items in here, these very same items. And so what it will have, though, is weights of 1/9, because there are only 9 items. But again, it's going to be the weights of the 1/9 times the sum from I equal 1 through 9 of the beta I. Okay, well, this thing has a value. We could just solve this expression right here for that value. In particular, let's look at what this says. It says, solving this, that 1.20 equals 1/10 times whatever this sum is of the beta I from 1 through 9, plus 0.75. Well, let's go ahead and solve this through. 10 times 1.20 equals this. If we subtract off 0.75, this is the value of I equal 1 through 9 of the beta I. It equals this amount right here. So all we have to do is to plug that in here, and if we take 1/9 of 10 times 1.20, subtract off 0.75, okay, so solve this in the parentheses, divide it by 9, you'll also get 1.25. So this was the A-level question in here, but you had a variety of different ways to go about solving that. They all depended on the identity that you were given, that is beta of a portfolio is equal to the sum of the weights times the betas of the individual items. And that's true of the new portfolio as well as the old portfolio.